All right, so here we're supposed to sketch graphs of the function f and g on the same axis like we've been doing, and then shade the regions between the graphs. And then we're supposed to solve for the input values at which the graph of f and g intersect, and then we're supposed to calculate the difference in the area of the region between the graph of f and the horizontal axis, and the area of the region between the graph of g and the horizontal axis from A to B, and then calculate the total area of the shaded regions. All right, so first off, let's graph those to see what they look like, and let's do part A and B together because that's going to be the same. So again, I've plugged in the equations and I've kind of expanded it from 0 to 5 because we only are doing 0.5 to 3. And so it looks like we have, our f of x, this is our g of x. And so that's going to be kind of what the great graph looks like. Now we're going with 0.5. So 0.5 is about here. So we're going to go from like this point up to, it said 3. So it's going to be over to here. And so it looks like the shaded regions here and here. So a little bit of red higher, a little bit of blue higher. And so now the next thing we need to do is that intersection point. So let's go ahead and do that. And it looks like it's at 1.134 and 1.763. So let's draw what we have so far. All right, so let's maybe put it up here. So we have, and we don't probably need that long down the bottom actually, but that's okay. It was coming down, and this one was going up. This is our intersection point, which we said was 1.134, comma 1.763. And we're going from 1, so we're doing this area, up to 3, which is a little further out. Oh, actually, it's 0.5, not 1. And so that's going to be our thing. So this is, again, 0.5. This is 3. And the upper one was our f of x, and our lower one was our g of x. So we've done A and we've done B. All right, so now we need to do C. So C says calculate the difference in the area of the region between the graph of f and the horizontal axis, and the area of the region between the graph of g and the horizontal axis. So, well, what are we going to do? Well, we're going to basically do the following. We're going to take our integral from 0.5 to 3 of our f of x, and then minus our g of x and dx, and that should give us a value. So we're taking y1 minus y2. So math 9, 0.5 up to 3 of alpha 1 minus alpha 2 and x. And we should get 2.812. Okay, so we get 2.812. And there's no units here, so we don't have to worry about units. And so now that's our area of the region. Okay, so the f of x minus the g of x, so there's more f here than g, and so that's why it's positive. If we had taken g of x minus f of x, because there's more f, it would have become a negative value. All right, so now let's do D. Well, D says calculate the total area of the shaded region. So we need to find basically, the area here and then add the area here. So we're going to have to use that inflection point. We're going to go from 0.5 to 1.134 and do the g of x minus f of x. And then we're going to add to that our f of x minus our g of x from 1.134 up to 3. So let's write all that down. So we're going to go from 0.5 to 1.134, and we're taking here g of x minus our f of x dx. And then we're going to take, after that, we're going to add our integral from 1.134 up to our 3, and that's going to be from f of x minus our g of x and dx. All right, so let's see if we can put that all in one line so we make it easier on our calculator. So we're going to go from math 9, 0.5 up to, it was 1.134, And that one, we were doing g of x, so that was alpha trace 2 minus alpha trace 1, and then dx. And then we're going to add to that the math 9. Now we're going from 1.134 up to our 3, and now we're taking f of x, which is alpha trace 1, minus alpha trace 2, and then our d of x. Now, that should give us what we just wrote down, and so we get 4.172. All right, so that is the total area. That is the area under the curve, f of x minus g of x. Again, larger piece minus that smaller piece still gives us a positive. And so this was A and B combined, okay? So that's how we're gonna do that one. So hopefully that will help you there. Now we're gonna do the same thing here. And so we're gonna go back to our calculator and look at what we have and draw pictures and do all that stuff. All right, so once in our calculator, our two equations are this, and they look like this. And so what we were supposed to do is go between 0 and 6, so 2, 4, 6. So probably pretty close to this here point, but we're not for sure. So what we need to do is we need to find this intersection and this intersection, because those are going to be kind of where they change. So trace 5, sure. So this one we get 3.512 and 7.107. Then we're going to oops. Then we're going to do it again with this one. Now let's choose the same graphs, but now we'll get closer to the other intersection. And our intersection here is 6.116 and 8.670. All right, so let's draw that. So let's see if we can get that drawn. Again, or basically on above the axis. So, we can kind of do that. This was kind of coming up, down, up, down. And then we had the straight line, and it was coming through kind of like that. Again, not to scale, but that's okay. And we said we're going to go between 0 and 6. So we know that it's going to be all this area. And this intersection was 6.116 comma 8.670, and this intersection was 3.512 7.107. So 6.110. So if we're drawing a graph, it's not going to be all the way to that piece there. It's going to be close, but no cigar. So that's going to be the two areas we're going to look at. Again, this one is our g of x, and the one going up and down, that was our f of x because of the sign. It's the oscillation, okay? So that's part A and part B, all right? So let's write that down. That's A and B. Now C, it said to do basically the area that's under the curve overall. So basically we're going to take the larger minus the smaller, and it's first is f of x. So we're going to basically do 0 to 6 of basically our f of x minus our g of x dx. Okay, so let's go do that. And so quit there. So we're going to go math 9, and we're going from 0 to 6. 0 to 6 of our alpha trace 1 minus alpha trace 2 and x. And so that should give us this area. So 19.519 roughly. Okay, so that's going to be the difference. And D asks for this area plus this area. So here we're going to have to take the integral from 0 to 3.512, which is our intersection point. And the bigger one is the sign, so it's going to be f of x. So we'll take f of x minus our g of x here, dx. And we're going to add to that the integral from 3.512 up to our 6. And this time our g of x is larger, so we'll take g of x minus our f of x dx. And so let's see what we get there. All right, so we're doing something wrong here. That's 5. No, it's 0.6. I was like, whoop. All right, so we'll go do that. Yeah. So now we're going to do second quit. We're going to do math again, 9. And so we're going from 0 to that 3.512. And then that's going to be 4. And we're taking our f of x again. So alpha trace 1 minus alpha trace 2 x. And then we're going to add to that the integral from 3.512 up to our 6. And this time we're going to take alpha trace 2 minus alpha trace 1 and x. And this should give us our value overall. So 39.116. So this area is the total area of the shaded regions. This area is the region under f of x, but above g of x. So kind of, between those two, taking the upper one, and then also now it's below, so we have to subtract it off basically, and that's going to be that region. All right, so that's 2 examples of looking at area between curves with our intersection point. So let's pause there and we'll come back for more.